So what we want to work on today is finding some lengths or the distance of different segments. So here we have a figure. We've got triangle ABC. And we want to find the lengths of segment AC, BC, and AB. Well, what you might want to think to yourself, some of the lengths that we could find pretty quickly would be AC. It's a vertical segment, and we can count the units to find its length. We also could find BC pretty quickly because that's a horizontal segment. We could count the units for its length there. So we know that the length of AC should be 3 units, and BC should be 5 units. The question is, how long is segment AB? Because it's not vertical or horizontal, we cannot count the number of units for its length. So there's got to be another way to find its length. And in the past, one of the ways that you could have found the length, because it is a right triangle and you know the two lengths of the legs, was using the Pythagorean theorem to find it. And the Pythagorean theorem says the sum of the lengths of the two legs squared is equal to the hypotenuse squared. And sometimes people refer to it as a squared plus b squared equals c squared, where a and b represent the length of the two legs of the right triangle. The two legs that are making up the right angle is equal to the hypotenuse. So we can implement that to find one of the missing lengths for our right triangle. Again, this is only for right triangles when you know two lengths and you're trying to find the third missing one. Whether it's a hypotenuse or a leg, you could use this theorem to help you find it. So let's go back and take a look at our triangle and see how we could find the length for AC. So again, we said this length here is 3, and this was 5. So remember, the sum of the two legs squared is equal to the hypotenuse squared, which is what we have here. And we know that 3 squared is 9, and 5 squared is 25, and that's going to equal the hypotenuse squared once we add those together. Well, 9 and 25 would be 34, and so this is the hypotenuse squared. We just want the hypotenuse, so to undo something that's squared, we have to take the square root of each side. And we know when we take the square root of something squared, that gives us the absolute value. And we look at the value and ask ourselves, well, can we do anything with the square root of 34? We know that if we put in our calculator, we would get a decimal equivalent. So for right now, if we're talking about the exact length, I would just leave it as is, the square root of 34. If you were asked for a decimal approximate, you could use that as well. So we're just going to say the length of AB is the square root of 34 units, and we are all set. So let's see if we can find some other lengths. Here we want to find the length of our segment AC. And so if we notice, it's not a vertical segment, it's not a horizontal segment, but we could kind of vision a vertical and horizontal segment there to make a right triangle, make it similar to our warm-up. So if we drew those in, we'd have a vertical segment of 1, a horizontal segment of 6, and that's forming our right triangle. We could implement the Pythagorean theorem for that as well. So remember, the sum of the two legs squared is equal to the hypotenuse squared. So 1 squared plus 6 squared is equal to AC squared. Well, we know 1 squared is 1 and 6 squared is 36, and we add those together, we'll get 37. And that's equal to the hypotenuse squared. So if we undo the squared with the square root, okay, we know that the length of AC should be the square root of 37. If we want to do the decimal approximate, we say approximately 6.1 units. But the square root of 37 units is just fine. So let's try another one. Can you find the length of your segment BC? Using the tactics that we had before, we can make it a right triangle with legs of 3 and 6, and we know the sum of the two legs squared is equal to the hypotenuse squared. So performing your order of operations, we have 45 equals the hypotenuse squared. To undo something that's square, we could take the square root of each side. And we see that the length of CB is the square root of 45 units, or approximately 6.7 units in length. Now, when we have our grid paper and we have the points and we have the segment drawn for us, Pythagorean theorem is a quick tactic to use to find its length. But is there another way that we could find it instead of always using the Pythagorean theorem? So is there a shortcut, another method to use? And some of you may have seen this in the past. Yes, there is another way. We could manipulate the Pythagorean theorem to solve for the length of the hypotenuse all the time, which would save us time and steps. Hopefully it would be a little bit more accurate, and we call that the distance formula. So let's show you what the distance formula is. So the distance formula, we said it's manipulating the Pythagorean theorem, so we're just getting the hypotenuse alone. So remember, the Pythagorean theorem was saying the sum of the two legs squared is equal to the hypotenuse squared. One was coming from the horizontal segment, and one was coming from the vertical segment. Remember, horizontals, those are your x values, and the verticals are your y values. So we're just kind of substituting those things in, how we were counting the lengths with the units. That's what we're happening here. This is what if we did y minus y, that gave us the units vertically for the leg, and x minus x gave us the units horizontally for the leg. And so remember, what we did was we were adding those two amounts together, right? And to get the hypotenuse alone, we took the square root of each side. And the hypotenuse was what we were trying to find the length of. So we say, hey, that's the distance we want to find. We can do this pattern instead of the Pythagorean theorem. It's coming from the Pythagorean theorem, right? But the distance that we want to know is already isolated. So if we just substitute the coordinates in for the 2 points, that will help us get there. So let's see if we can use this to find some different lengths as opposed to always going back to the Pythagorean theorem to do that. Okay, so the distance formula, right? You're still taking the length of the one leg squared plus the length of the other leg squared and taking the square root to find it. So here we have our segment DF. Could we find its length by using the distance formula? So let's think about the distance formula. We need to know the coordinates for the 2 points. So we know D is at 1, -2, and F is at 7, 2. We're going to take the difference of the x values, because that would give us the length of this leg here, and the difference of the y values, because that would give us the length of this leg here. And then we can use those two to find this. So let's substitute those values in, right? The difference of the x's and the differences of the y's. So 7 minus 1, that's 6. And 2 minus -2, remember this is telling you take the opposite, so it becomes a plus, that would be 4. Now I have to square each. 6 squared is 36, 4 squared is 16. Add those together, we get 52. So the length of DF would be the square root of 52 units. If we wanted to get the decimal approximate, we could use the calculator and say it's about 7.2 units, but both of these would be fine. I personally would leave it as the exact value right now as opposed to the decimal, but again, they're approximately the same. So we've been talking a lot about finding the lengths of the segments, but what does it mean if we have a midpoint? Where would it be located? Well, midpoint, what is the key word that you see? Here, mid. Hopefully you think of it as the middle. So a midpoint is the exact middle of a line segment, because remember, a line segment has a definite beginning and a definite end. It's a set length, so you could find the exact middle from each endpoint of it. So how can we know where it's located? The same distance away from each endpoint on the segment that it lies on. So if it's halfway between, that means it's bisecting the segment into two congruent parts. So from one endpoint to the midpoint, that would be the same as the other endpoint to the midpoint in length. So if we had some segments, could we find the coordinates for the midpoint? So we've got the segments with their endpoints noted, and we want to find the coordinates for the midpoint of AB. So here's AB. Do you know where the midpoint, the middle of that segment is? Could you tell me its coordinates? Well, because AB is a vertical segment, right, we could count its units to find its length, or you could use the distance formula if you want to find its length, but we know the length of AB is 5 units. So the midpoint M has to be 2.5 units away from each of those endpoints. So if we count 2.5 units from A or 2.5 units from B, the coordinates would be -6, -0.5. Well, what if we wanted to find the midpoint for CD? Could you tell me its coordinates? Well, CD is a horizontal segment, so we could count its length, and we know that CD is 6 units in length, so the midpoint M would have to be 3 units from each endpoint, C and D. Well, if I count 3 units away from C or 3 units away from D, what coordinate does that bring me to? That brings me to 1, -2. So what if we want to find the midpoints for segment EF? Well, segment EF is not like segment AB or segment CD because it's not vertical or horizontal. But are there things that we could use in the past to help us? Well, in the past, when we were looking for the length, we drew a right triangle, right? And we looked at the vertical distance and the horizontal distance. And we were using those lengths to find this one. Well, vertically, that's 2, and horizontally is 4. So if we're thinking about the middle, that would give us the entire length, right? So the middle would be half of that. So instead of going 2 down, what if I only want half that distance? 1 down. And then instead of going 4 units to the right, what if I want half the distance? 2 units to the right. That would help me find the middle, right? So my midpoint would be at -1, 3. So we're kind of using the idea of slope, right? How are we traveling from one endpoint to the other to find the middle of that segment? So let's see, can we do another one? Can you find the coordinates of the midpoint for GH? GH is similar to EF, so if we kind of use the idea of slope, right? We're going up 1 unit and to the right 4 units. So if we use that and think about, well, let's travel half the amounts. Instead of going up 1 unit, let's go up half a unit. Instead of going over 4 units, let's go over half that, which would be 2. That would bring us to the point 4, 1.5. So graphically, we have some nice ways of finding the midpoints of segments. Is there another quick way that we can find the midpoints of always doing the slope to help us with that? And there is. Just like we were doing before, maybe you noticed a pattern with the coordinates of the endpoints of the segment, like you were doing with the distance formula, to find the midpoint. And so we've been talking about, right, the changes in the y's and the changes of the x's, and to find the middle, right, we're taking the average of those. So here we have kind of a pattern, a formula for midpoint. So when you have the endpoint coordinates, right, if you average the x's and you average the y's, that would give you the midpoint for your segment. So we don't have to plot the points anymore to find the middles using the slopes. We could just substitute the coordinates in, implement our pattern, and we'd be good to go. So let's show you again what we were talking about. If we just had the coordinates, right, for the last one, and we had the average of the x's, right, 2 and 6, that's 8. Half of that would be 4. Averages of the y's, 1 and 2, that's 3. Half of that is 3 halves, or 1 1/2. We see that the pattern holds true. So if we took away the graph, could you still find the midpoint of a segment if we just gave you the endpoints? Sure we can. We're just going to implement the midpoint formula. Remember, we're just going to average the x coordinates and average the y coordinates, and we'll have the middle. Well, our x's are -1 and 6, so we're going to add those together and take half that amount. And then we're going to do the y's. 2 and 1, add those together and take half. Well, -1 and 6, that would be 5. So we'd have 5 halves. 2 and 1, that's 3. So we'd have 3 halves. So we could leave it as 5 halves, 3 halves. If you also want to write it as a decimal approximate as 2.5, 1.5, that would also be correct. Personally, I always go with the fractions. I think that's a little bit more helpful sometimes, but again, they are equivalent to each other. How about this one? Can you find the length and the midpoint for segment XY when X is located at -4, 3 and Y is located at -1, 5? So if we start with the length, right, thinking about the distance formula, we're going to take the difference of the x's squared plus the differences of the y's squared and take the square root to find our results. So if we substitute in what we know, right, here's the difference of the x's. Remember, subtracting a negative, saying, hey, take the opposite, so that's a positive. -1 and 4 is 3, and 3 squared is 9. The differences of the y's, 5 minus 3 is 2, 2 squared is 4, add them together, we get 13. So I could say it's the square root of 13 units, or if we want the decimal approximate of 3.6 units, we have the length for our segment. Now, if we want to do the midpoint, we're going to take the average of the coordinates for x and y. So if we substitute our values, averaging the x's, -4, -1, that would be -5, and take half of that. Average of the y's, 3 and 5, that's 8, take half of that. We could say, hey, -5 halves, 8 halves, but we could also write it as -5 halves, 4, or maybe you even wrote it as -2.5, 4. I would prefer this one, but both of these would be equivalent coordinates, the same location for your segment XY. How about this? Can you find the length and midpoint of segment AB, where A is at 2, 8, and B is at -2, 2? Well, starting with the length, if we substitute our coordinates into the distance formula and follow our order of operations, we have -6 squared, which is 36. -2 minus 2, remember thinking at -2 at the number line, going 2 to the left of that to get you to -4. -4 times -4 is 16. Add them together, we get the square root of 52 units, or approximately 7.2 units in length. For the midpoint, we average the x's and we average the y's. So we have -2 and 2, which is going to be 0. 0 divided by 2 is 0. 8 and 2, that's 10. 10 divided by 2 is 5. Here's our midpoint at 0, 5. And that concludes our quick review and lesson on finding the length of segments and midpoints graphically and algebraically. And now you're going to do some practice with that. If you have any questions, as always, please email your teacher, and we're happy to help. Have a good day.